So we looked at arithmetic sequences, and those are sequences that go up by a common difference every single time. They go up by 2. So 2, 4, 6, 8, 10, 12, and so on and so forth. The other type of sequence that it's important to know are called geometric sequences. Now, in geometric sequences, your terms are multiplied by some value, right? And so a good example of that would be like numbers doubling. So like if we had 1, and then we double it, we get 2, then we double it again, we get 4, and we double it again, we get 8, 16, 32, and it goes on, and it explodes really fast, right? And so a good example of geometric sequences is actually exponential growth. It goes up really fast. Or exponential decay, where it goes down when we're multiplying this number as a fraction or a number less than 1. And so then it'll get really small. So that constant value that we multiply every time has a special name too. And we call that the common ratio. Okay, so ratio, remember, is something that we'd multiply by. So the common ratio is what we're going to multiply our geometric sequences by to find the next terms. Okay, so let's look at a couple examples. All right, so the first one, it says, determine whether each sequence is geometric. So if I'm going from 2 to 6, I got to figure out what I multiply -2 by to get 6. Well, I multiply it by -3. And so when I take -2 times -3, I get +6. Let's do the same thing to 6. 6 times -3 is -18. And then the next one, -18 times -3 is 54. Now, how do you think I can figure that out? Well, an easy way, before we said you would subtract the second term from the first, but in common ratios, we're actually going to divide. So if we wanted to figure out R, we would take the second term over the first, right? We call them A1 and A2 for terms, right? And so in our case, it would be 6 over -2, which is -3. And if we did that the whole time, so if we took like, if we did -18 over 6, we'd get -3. And we could divide them every time and make sure that we get -3. So let's apply that idea to the next question. Okay, so the next one says, I have 16 and 8. So 16 divided by 8 is 2, right? And so then I go to the next one. 24 divided by 16 is actually 1.5. So that is not the same number that when I divide. So it doesn't have a common ratio. So this is not geometric. Okay, so that's not a geometric sequence. The first one was. And so I guess we could say that that's geometric up here. Okay. All right, so let's apply this to a problem where they give us our first couple terms, we can find the next, right? So it says, consider the geometric sequence 32, 8, and 2. Find the next 3 terms, okay? So to do that, I got to figure out what my common ratio is. And so I'll do A2 divided by A1. So that would be 8 divided by 32, which is 0.25 or 1/4. And so that's my common ratio. And I can check that with the next one. And that would be, 2 over 8, which is also 0.25, which means I'm going to multiply every term going forward by 0.25. And so when I do that with my next term, 2 times 0.25, that's going to be 1/2, right? And then I take that times 0.25, and I'm going to do this on my calculator. I get 0.125, okay? And then times that by I get 0.0625. So it's getting very small. And so if we were asked to graph these, right, we would think of them as, again, x's and y's, right? And so my term would be, the first term would have been 32. And then my second term would have been 8. Third term was 2. Fourth term was 1/2. Fifth term was 0.125. And sixth term, 0.0625. So if I graphed these and I had 132, it'd be like way up top, right? And then I'd get 2, 8. Okay, and then I'd get 3, 2, and then I'd get 4, 1/2, and it's going to get super duper small, right? And so my graph ends up looking kind of like this, which makes sense because when we talked about exponential decay, when you were multiplying by a number less than 1, they got really small, and its asymptote was the x-axis. It got really, really small, but never went below 0. So that's important going forward. So we remember that arithmetic sequences look like lines, where geometric sequences look like exponential growth or decay. All right, and so here's two really good pictures of what they look like, right? So we see that arithmetic sequences form straight lines, where geometric sequences explode in size, right? Super important to know that going forward, okay? So our sixth example right here, they actually want to know, okay, so what type of sequence is each one? And they want you to explain. So the process in which I do it is I start by thinking it's arithmetic, and I try and figure out the common difference. What am I adding every single time to make sure that it's the same thing, okay? If it's not arithmetic, then I try geometric, and I divide the second by the first term and see if that's the same number. And if it's not arithmetic or geometric, it's neither, okay? So let's look at the first one. So let's find the common difference then. Let's see if it's got a common difference. And we did A2 minus A1. So in this example, it would be 24 minus 16. And when I do that, I get 8. Okay, so let's try the next one. It's going to be A3 minus A2, which would be 36 minus 24, and that's 12. And so I notice that those two are not the same. So this is not arithmetic, okay? So I get rid of all that, and then I try common ratio, okay? The common ratio, remember, is the second term divided by the first. So in this one, it would be 24 divided by 16. And when I do that, I get 3 over 2, or 1.5. Okay, I try the next one, A3 over A2. And so that would be 36 over 24. And again, simplifying this, I get 3 over 2. Okay, well, that's helpful. And then if I did 54 over 36, I'll just verify it on my calculator. 54 over 36 is also 3 over 2. So it for sure is geometric. Okay, so we know that the first example, A, is geometric. Okay, let's go to our next one. Okay, again, let's start with arithmetic, right? So we say common difference would be A2 minus A1. And so in our case, it'd be 4 minus 1, which is 3. Okay, then I go to the next one, A3 minus A2. That would be 9 minus 4, and that would be 5. Okay, so they are not arithmetic because they don't go up by the same number every time, right? The first one goes up by 3, second one goes up by 5. So it's not that. Okay, so it's not arithmetic. So let's try geometric then, and that's dividing, right? And so my common ratio then would be A2 over A1. And so that would be 4 over 1, which is 4. The next one, A3 over A2 would be 9 over 4, which is actually 2.5. So again, that doesn't go up by the same thing. That doesn't have a common ratio either. So if it doesn't have common difference and it doesn't have a common ratio, then this is neither. Okay? All right, let's look at our last example, letter C. Okay, so letter C, it says 23, 17, 11, and 5. And so what I'm going to do is I'm going to try and figure out, is this arithmetic by finding a common difference? So that would be 17 minus 23, which is negative 6. 11 minus 17 is also negative 6. And if I did it one more time, 5 minus 11, that's also negative 6. So this one would then be arithmetic. Okay? And that's all I have for you today. So hopefully sequences start to make a little bit of sense to you. If you have any questions, comments, concerns, please let me know as soon as possible.